So, of course, our unit wouldn't be a unit if we didn't do some word problems. So that's what we're going to be doing today. We're going to do some quadratic word problems. Now, we have done quadratic word problems, but it always involved your vertex. You were looking for when did it reach that maximum height, or what was that maximum height. This time it's going to be a little bit different. Now, as always with our word problems, first thing we need to do is identify what is it in fact that we are looking for. So we always need to determine our unknowns. Once we figure that out, we then are going to write our equation. These steps are nothing new. Remember, when you are solving your quadratic equation, you will get two answers. Sometimes you can keep both of the answers. Sometimes you have to get rid of one of the answers. So we'll go through how to figure that out. You want to check your answers. You may need to reject one, as I was just saying. And then you have to make sure you have answered the question and that it actually makes sense. So sometimes you take your answer and you have to do a little bit more work with it. So let's take a look at our first example here. We have the area of a rectangle is 36 square feet. The length of the rectangle is 5 feet more than the width, so find the dimensions of the rectangle. So first thing we want to do is actually to draw a picture of a rectangle. Because when it's talking about a rectangle, you should have a picture of a rectangle. So they tell us with that rectangle, the length is 5 feet more than the width. So the one that they mentioned last, the dimension that's mentioned last, is your width. So that's the one that's going to be your x. Remember, whichever one is mentioned last, that's always your x. So the length is 5 feet more than that. So how would I write 5 feet more than that? X plus 5. So there's our dimensions so far. We got an x and an x plus 5. So if we look back up here, they tell us the area of the rectangle is 36 square feet. So how do we find the area of a rectangle? Length times width. So I have to multiply my length and my width, and it's going to equal 36. So x times x plus 5 equals 36. So now we can start solving. We want to distribute first. X times x would give us x squared. X times 5 gives us 5x, and it equals 36. And then what do we do with our 36? Subtract it. We need it to be equal to 0 before we can do anything. So I got to subtract my 36 over. So x squared plus 5x minus 36 equals a 0. Now, we have two ways we could solve this. We could factor it, or we could use our quadratic formula. I'm going to go ahead and try factoring, because if it is factorable, factoring is always so much faster than using that quadratic formula. So my two sets of parentheses, our signs, will they be same or different? Different, because I got a negative at the end, so x plus, x minus. And then, so we're looking for multiplies to give us 36, but we'll combine to give us a 5 in the middle. So let's think about it. What multiplies to give us 36? We got 1 times 36, 2 times 18. Remember that little trick I showed you how to make your list? You got to do 18 divided by x in your calculator. 3 times 12. There's 2 more. 4 times 9, 6 times 6. So which one will give us a 5? 4 and 9. 9 will be my positive, 4 would be my negative. So we set them equal to 0. So x plus 9 equals 0. X minus 4 equals 0. Subtract my 9 and I get x equals a negative 9. Add our 4. We get x equals 4. I'm going to put those up here. So I got -9 and I got a 4. Now, we got to check to see if we can keep both of those answers. If I had x equals -9, that means this side of my rectangle would be a -9. Does that make sense? Can I have a negative length? No. So I would have to reject this one. Now, if I have x equals 4, could this side of my rectangle here be a +4? Yeah, you can have a 4 as your length. Okay. So then I have to get my other side, though. So if x is a 4, what would be 4 plus 5? 9. So we would have to write a sentence. The dimensions are 4 feet and 9 feet. Got to make sure you include your units in there. So 4 feet and 9 feet. For this one, the picture is our let statement. So pictures can replace those let statements. Some people still like to write them. You always can.
No.
So next in here, I have a little setup for our consecutive integers again because they don't go away, so I like to review them. So if we are purely talking about consecutive integers, x is our first one. X is always our first one. Every word problem has x equaling something every single time. You always need one value that is purely your x. So if our first one's x, what would our second number be if they're consecutive? X plus 1. That means they're only one apart, would be your second integer. What would our third integer be? X plus 2. And that would be x plus 3, and then x plus 4. Our consecutive integers just keep going up by ones. However, with our evens and our odds, what do those go up by? 2. So again, the first one is still x, but the second one would be x plus 2. The third one would be x plus 4. The fifth one would be x plus 6. Whether it's even or odd, that does not matter. They always go up by 2s. So let's take a look at our second example on here. We have the product of two consecutive integers is 56. Find the integers using an algebraic method, which is everything we've been doing. That's an algebraic method. All right, so we're talking consecutive integers. What is our first integer? X. So let x equal first integer. But I need a second let statement because I need two integers. So they're just consecutive, so my second one is going to be x plus 1. Keep in mind, and consecutive means it's one number right after the next. So 3, 4, and 5, those would all be consecutive integers. So here's the part where people usually make little mistakes. So what does this word product mean we have to do? Oh, good. A lot of people think product means add. Product means we have to multiply. So that means we're multiplying our two numbers together. So x times x plus 1 equals 56, because the product of our two numbers is 56, so they multiply together to give you 56. So let's go ahead and solve this now. So we're going to distribute our x. X times x gives me x squared. X times 1 gives me a 1x. And then it equals our 56. So now what do we do with our 56? Subtract it. I need it to be equal to a 0 before I can finish solving it. So x squared plus x minus 56 equals a 0. Again, let's try factoring this one. So I'm going to set up my 2 sets of parentheses since we have a trinomial. Our signs, will they be the same or different? Different. And we're looking for factors of 56. What multiplies together to give us 56? What? We're not looking for the square root. We're just looking for 2 numbers that multiply to give us 56. Not 9 and 6. 28 and 2, but we're trying to get a 1 in the middle. So 28 and 2 are going to be a little bit too far apart for us. So let's find some other ones. 8 and 7. Which one would be my positive? 8. And then my 7 would be negative. So I'm going to move this up here just so people can try to see it a little bit better. X plus 8, x minus 7 equals 0. So I set each factor equal to 0. So my x plus 8 I set equal to 0. My x minus 7 I set equal to 0. Subtract my 8 and I get x equals negative 8. Add my 7 and I get x equals 7. Now there is a little tricky part to this one. Did it say anything in the beginning about it having to be positive or negative? No. So do I reject any of those? No. Now here's the other thing. Is negative 8 times 7 a positive 56? No. So what it is you have 2 answers here. So if x is negative 8, what would negative 8 plus 1 be? Negative 7. So here's one set of answers where it's negative 8 and negative 7. Now if x is 7, what would 7 plus 1 be? 8. There's our other set of answers. So when we write our sentence, we say the integers are negative 8 and negative 7, or positive 7 and positive 8. We have 2 sets of answers for that one. Okay. Thank you. So for our last one here, we have the flight of a baseball that was hit when it was 4 feet off the ground is modeled by this function here, where h is the height of the baseball in feet after t seconds. Rounding to the nearest hundredth, how long will it take before the ball lands on the ground? Show your work algebraically. So we have to keep in mind, if we were to graph that function up there, the graph would end up looking like that. So again, we're looking for when the baseball reaches the ground again, right there. So that means our height is a what?
4 feet. Oh, wait.
We're looking for it reaches the ground. So the height of the ball from the ground would be what? 0. If the ball's on the ground, it has no height. It's right down there on the ground. So we're looking for when h is 0. So we're going to take the equation that they already made for us and plug in a 0 for our h. So 0 equals negative 16t squared plus 75t plus 4. So now for this one, because they told me to round to the nearest hundredth, that's my hint that I have to use the quadratic equation. This one's not going to be factorable. So just like we did on our quiz, x equals negative b plus or minus square root b squared minus 4ac all over 2a. So hopefully you guys got that question right on your quiz.
I did.
Woo! So what's the A value in our equation?
16.
Negative 16. Our B value?
75.
And our C value? 4. So let's go ahead and plug those in. So I have negative parentheses, negative 16, plus or minus the square root. Really, you guys are going to let me leave the 16 there? What's my B value? What should be in that first one? 75. And then 75 squared minus 4 times negative 16 times 4. All over 2 times negative 16. So what I want you to do is I want you to practice typing that into your calculator and get your 2 answers. All right, does anybody got one of them for me? What do we got, Johnny? Negative 0.05, and then who's got the other one? Anybody?
The other one, like 2 seconds if you want.
Okay, I'm counting. 1,
Okay, give me like 5 seconds.
2,
Got it. It's
3.
4.7.
4 point what?
4.74.
There we go. That's not what you got? What'd you get? Oh, no. I'll take a look in a second, see what you did. So, can we keep both of those? No, because we're talking about time. So which one do we have to reject? The negative. You can't have negative time. We can't go back in time. We're not Michael J. Fox. So then, all we have to say is it will take 4.74 seconds for the ball to reach the ground.